Good day, sir. I hope you're doing well today. Thank you for taking the time to watch this presentation of my Flutter project. My name is Dubert Aaron Ipakio, and today I'm excited to present my Flutter mobile application project. This project represents my skills in mobile app development using Flutter framework, incorporating modern development practices and responsive design principles. Throughout these presentations, I'll walk you through application, features, and then answers the questions which you will given. So this is my home. It's just simple, minimalist. We have gallery and camera. We can also click that like that. Then gallery. So below the gallery is a tips on how to use. We also have navigation and below we can click history and analytics. So let's test it with kidney beans. Kidney beans. So kidney beans. So it's 100% kidney beans. So below the top predictions are the beans descriptions. So story and analytics is updated as you can see here. In story we have predictions, confidence level or confidence percentage, then scan, time and date. So December 19, 2025 at 3:54. Then total scans and analytics, average confidence, bin type distributions, confidence distribution, and recent activity. Then we move on to Adzuki. Adzuki. So this is Adzuki bin. So in the predictions, also the description below updated for what's on the top predictions. So now it's Adzuki beans. So the descriptions also updated to Adzuki beans. So Adzuki beans are small reddish brown legumes popular in East Asian cuisine, etc. Then scan story. It's also updated analytics. So now we have total scans 2, just like that in average confidence. So let's now test it on soybeans. So as you can see now, the soybeans is correct. But the predictions, it's now soybeans. It's like that. You can also choose in gallery soybeans, just like that. Then proceed to what is this called garbanzo beans. So now it's garbanzo beans. So now the garbanzo beans are predicted. So garbanzo beans, also known as chickpeas, are nutritious versatile legume. So now let's proceed to green beans. So green beans. So just like that, green bean is predicted. And you can see in history, bin type, gallery. You can also check. It's like that, green bean. And now we have 2 green beans and 2 soybeans. Total scans of 7, average confidence 96.3. Can proceed to black beans. Can try this one. So as usual, black beans detected. Just like that. Black turtle bean is a small, shiny variety of common bean. Story. Then we can proceed to pinto beans. So pinto beans is just like a normal bean but have a small pattern or black pattern, black or brown, just like that. What you see in here, then like that. Oh, beige skin with reddish brown speckles that fade to solid light brown when cooked. So that's the characteristics of pinto beans. Now we can proceed to lima bean. So lima bean is like green, it's like this, green flat beans, and just like that, lima bean is predicted. So no other one. Analytics. We now have total of 10 scans. You can check the gallery for lima. This is the lima bean. Like that. Then proceed to navy bean. So navy bean is like a white bean, like this. This is a navy bean. A total opposite of black beans. Just like that. Navy beans is predicted. Then mung bean or munggo. So mung bean is like that. Mung beans are small green legumes, vital in Asian cuisine. So this is munggo in our dialect. Then as you can see here, 12. Then we can check the gallery for this garbanzo. This is munggo, mung bean. This is navy bean, white. This is the pinto beans, 82. You can also see the adzuki beans. It's like that. In our history, total scans. Then we need to include kidney beans and black beans. Just like that. In the story, you can now see the kidney beans and black beans analytics 2020. So I think with this it more. One more. So on kidney beans, this is kidney beans. Or we can choose another one, another picture for kidney beans. This one. So kidney beans. So this is kidney beans. Now with a small percentage of pinto beans and adzuki beans. Then adzuki beans. We can select another picture for adzuki beans. What picture? I think this one. Oh, here we go. So adzuki beans, as you can see. So adzuki bean wins because of a lot of percentage. This is now the bean type distribution. So we need one more on each: black beans, pinto beans, navy bean, mung bean, garbanzo beans, lima bean, and green beans, soybeans. So now let's proceed to soybeans. We need to pick another one, another picture. So now it's soybeans. So soybeans predicted. So as we can see now, 72%, but still 72% is way above navy, lima, garbanzo, and pinto beans. So it's still the highest. So we can take that. Now it's time for garbanzo beans. For garbanzo beans, also called chickpeas. I think this one can predict my predictions. Yeah. So now it's 95% chickpeas, garbanzo beans. You can also see it in history. And therefore, then black beans. We need to black beans or green beans. We can see the green beans right here. This. So verdict. Yes, green bean. Green bean, then black beans. Pick another black beans. This one. Yeah, no. Still black beans. Then time for pinto beans. Another picture. So yes, it's recognized pinto beans. Then lima beans. So for lima bean, we can I think this one. So lima bean, yeah, 67. It's not bad. It's still highest among all beans. We'll take that. Then navy again. Under picture. Just scan. Oh my god, super. Then look here, 99%. Then last is munggo. Mung bean. What's this? So mung bean is 52%, but still it's the highest compared to all bins, all predictions. So that's it. I can also pursue bins like that. So we can now see also the latest is on the top and the bottom is the oldest. So we can see that when we, for example, we choose this picture like green bin, this green bin is now on top because it's the latest. So like that. Analytics is now 93.5. And total scan 33 total scans. Confidence distribution is like that. So below 60% because of that mong bin we see earlier. So the confidence distribution we now have 25.5111 and recent activity you can see it here. So that's all for my walkthrough of my bin scanner. Questions and answers. So first is what coding or architectural practices did you apply to keep your Flutter project clean and maintainable? So in developing this Flutter project, I implemented several key coding and architectural practices to ensure clean and maintainable code. First, I adapted the provider pattern for state management, which separates business logic from UI components and makes the code base more testable. I organized the project using a feature-based folder structure, grouping related files together for better navigation and scalability. I also followed solid principles, particularly the single responsibility principle, by creating focus, widgets, and services. Additionally, I implemented consistent naming conventions, added comprehensive documentation through comments, and used Dart's strong typing system to catch errors early. For code reusability, I created custom widgets for common UI elements and established a centralized theme system for consistent styling across the applications. Second questions. How did you ensure that homepage layout remains responsive across different screen sizes? So to ensure the homepage layout remains responsive across different screen sizes, I employed several Flutter responsive design techniques. I used media query to dynamically adjust layouts based on screen dimensions and orientations. The layout was built using flex widgets like row and column with appropriate main axis and cross-axis alignments. I implemented percentage-based sizing using Layout Builder to calculate dimensions relative to the parent widget sizes. For text, I use responsive text scaling with theme of, thick stem, and adjustable font sizes. I also utilize the expanded and flexible widgets to create flexible layouts that adapt to available spaces. Additionally, I tested the app on various screen sizes using Flutter's device preview and implemented conditional UI elements that show or hide based on screen width, ensuring optimal user experience on both phones and tablets. So, and third question is, what type of data do you store in Firestore, and how is it structured? So, for Firebase integration, I structured the Firebase with the users collections containing individual user documents, each, each with a scan subcollection storing scan results as documents. So each scan documents contain the bin type, confidence score, timestamp, and image path reference to Firebase storage. The structure follows a hierarchical pattern where each scan document includes fields like bin type, strings, confidence, double, timestamp, and image path string referencing Firebase storage, and created at server timestamp. Additionally, I implemented an analytics collection that aggregates scan statistics including total scans, average confidence, and bin type distribution counts. This Firebase structure enables efficient query, real-time updates, and proper data relationship while maintaining scalability. So that's all for my project, sir, and God bless.